you some suggestions on how to approach for a PhDs abroad, especially in Australia and South Korea. So yeah, so let's get started. So this will be the outline of my today's presentation. So I will briefly give you some information about my uni, that is University of New South Wales, Sydney, Australia, and then the different faculties that we have in our university and the different courses that our university offers, especially for undergraduate, masters, and the PhDs. Then I will proceed further to the actual topic of today's presentation by giving an overview of the need of an alternative renewable energy sources, and then why we need these alternative renewable energy sources. So mostly I will talk about the solar energy and how we can convert this solar energy for our day-to-day life uses, like for example, for electricity conversion. After this brief introduction on this need of the renewable energy sources, I will explain what is photovoltaics and what is photovoltaic effects. Then I will talk briefly or roughly on the basics of semiconductor and the p-n junction, which is considered to be as a base of the solar cell. And I suppose that most of you must have studied earlier. Most of you guys have studied this earlier in probably in your undergraduate or in even masters. After that, I will then explain how this solar cell actually works with some demonstration of the actual process using some animation, and then I will discuss the several parameters that are used to characterize these solar cells. And then finally, I will tell you the different types of or the generation of the solar cell, and then their efficiency progress if I have enough time. Finally, I will provide you some guidance on the PhD opportunities in Australia, especially in UNSW, and then also in South Korea, where I spent several years during my PhD and my postdoctoral work with the Dr. Kishore Guru sir as well. So let's get started. So the University of New South Wales is in Sydney, Australia. You can see on the map. So this Sydney city is one of the most populated city located on the east coast of this Australia. It takes about 12 to 15 hours, depending on the airlines, to come from the India, especially from Mumbai to Sydney. So about our university, our university has been established in 1949, and it ranks 44th in 2021 QS World University Ranking, 76 in 2021 Times Higher Education World University Ranking, and 74th in 2020 academic ranking of world universities. So you can basically say that our university ranks among the top 100 universities in the world. So this university has total 9 different faculties. I will basically introduce about the engineering and the science. That's what we belong to. So this UNSW engineering faculty has 9 different schools, like biomedical engineering, chemical sciences and engineering, civil and environmental, computer science and engineering, electrical, mechanical, minerals and energy sources, and UNSW School of Photovoltaic and Renewable Energy Engineering, where I'm working. And then the science faculty has different schools, that is School of Aviation and the Biological, Earth, Environmental Sciences, Biotechnology and Biomolecular Sciences, School of Chemistry, Matter Science and Engineering, Mathematics, Optometry, Physics and Psychology. So this our school, that is School of Photovoltaic and Renewable Energy Engineering, is I can say is one of the top school in the world, and it is well recognized for its research in solar cell, that is photovoltaics. So this School of Photovoltaic and Renewable Energy Engineering have a state-of-art facilities for fabricating the high-efficiency solar cell, not only silicon but also the new generation of the thin film solar cell, and also recently emerging the perovskite solar cell technology. We also hold the world record efficiency for all of these 3 types of solar cell technology in the world. So I'm going to talk about these different 3 types of generation of the solar cell, that is silicon, thin film solar cell and the perovskite, in the last slides of my presentation. So I will briefly give you the ideas of the solar cell. So, all right, let's go ahead and get started on the actual topic of today's presentation. So, yeah,
Mahesh sir,
so,
1 minute.
yeah, yes, sir.
Our
Yeah.
meeting will be end within 4 or 5 minutes. So, from product end, you can join. Okay.
Oh, okay, okay,
Okay.
okay,
Hmm.
okay, sir. Okay, no
Okay.
problems. Okay.
Okay. Hmm.
So yeah, we all know that we are using fossil fuels in excessive amount, so which is responsible for increasing the CO2 emissions, thereby accelerating the climate change and the threatening the natural ecological balances as a consequence of the this global warming. So this picture basically shows the effects of this our aggressive use of the fossil fuels on our day-to-day on our daily lives. That is, there are a lot of different effects like such as the changes in the plant's life cycle, rising the sea level, damaged corals, that is damage the sea life. Also, it leads to the warming the oceans, which again leads to the rising the sea levels, and many more things that you must be aware of. So this is the reason we must find some suitable alternative renewable energy sources to solve the issues associated with the use of these non-renewable energy sources that are contributing to the global energy, such as the fossil fuels. So, among the different renewable energy sources, the solar energy is, we can say, is world's most abundant energy sources. It has been predicted that, or it has been proved that enough sunlight reaches us every 15 minutes to power the world for an entire year. And most importantly, this solar energy is a safe and a clean energy source that powers house, businesses, and the power plants everywhere. So let's see how we can utilize this solar energy. We can utilize this solar energy either directly or indirectly in a variety of aspects, such as the solar thermal plants, as shown in these schematics. And then the next one is the photovoltaics, and then another one is solar water heating systems that you guys know. And then finally, the artificial photosynthesis. So today we will mostly talk about the photovoltaics, that is solar cell. But let me tell you briefly what are these two different the aspects that we can use to utilize the solar energy. So the solar thermal collectors, such as the solar hot water panels that you can see on the houses we mount, especially to heat our waters. I mean, like for hot waters. So which are the commonly used to generate the solar hot water for the domestic and the light industrial application. And then the photovoltaics, that is solar cell technology. This implies that actually the solar cell or solar PV arrays, which is made of the number of the solar cells stacked in the series, uh, which is used to convert the sun energy, or you can say the energy from the sun, into the electricity, which we can use then again to power the equipment or to recharge the batteries or to power the electrical appliances at the home, like tube lights and the bulbs, even the TV and the refrigerator or the fan, almost everything. And what is this artificial photosynthesis? So this is the another way to utilize the solar energy. So this artificial photosynthesis is a way of mimicking the natural process that the plants use to create the energy from sunlight, carbon dioxide, and the water. I'm pretty sure that you guys, I mean, most of us know what is the natural photosynthesis. I guess we have studied that in our high schools. So I'm not going to talk about that natural photosynthesis process, but just try to understand what is the artificial photosynthesis process. So this process is like the researchers are trying to mimic this natural photosynthesis at the laboratory. I mean, like inside the laboratory to use this sunlight to create some useful products such as the hydrogen and the oxygen. So we don't need oxygen a lot, but we need hydrogen. Okay, but I'm not going to talk in detail about this artificial photosynthesis. Maybe if I get a chance some other time, hopefully I will talk about this artificial photosynthesis again. That's because this is also one of my research topic, and I'm working a lot on this artificial photosynthesis these days. And I'm pretty sure this is also a kind of some interesting topics, just like a photovoltaic solar cells. Uh, so so let's see. So before we get started, I will just briefly introduce, not introduce, I will just briefly make you aware of the history of the photovoltaics. So uh, uh, I'm sure most of you must have been aware of this history of photovoltaics, but still, let's know a bit about it again. So in 1893, this Edmond Becquerel discovered the PV effect while experimenting with an electrolytic cell made up of two metal electrodes placed in an electricity conducting solution, and then the electricity generation increased when the light was exposed. So after that, after this photovoltaic effect, uh, this Dr. Smith, he observed again the